This is the Intro to Radiology lecture, and specifically this is where we talk about the X-ray machine and its components and the production of X-rays themselves. Okay, the X-ray machine components and their functions, and by this point you've seen them in lab, so you're familiar with the different parts and what they look like, but just to make it official and give you their purpose, you have the control panel, and that's what has your power settings, your knobs and buttons for adjusting between a child or adult, or depending on the image that you're going to take, you can adjust the time settings and all those. All of those adjustments and things are all made on the control panel, as well as the power switch. The X-ray tube head is the part that when you're adjusting the machine, you bring the tube head over to the patient, and it's close to their head, and it's the part that's at the end of the extension arm. But the tube head itself houses the X-ray tube, and we're going to talk about the specific parts of that in just a second, but the tube is inside the tube head, so that's why it has that name. The extension arm, kind of self-explanatory. It's the portion of the machine that's used to stretch the tube head from the wall unit over to your patient. So it suspends the tube head. It also houses the electrical wire so that when you press the button on the control panel or out in the wall, it's the extension arm that carries that signal to the actual tube itself to start making X-rays. The different electrical parts inside the machine, you've got the tube head, and I actually did a separate video talking about all the specific parts of the tube. In that video, I've got the slide with little boxes covering all the names, and you can move them to see what they are. I did that so that you would be able to look at the PowerPoint outside of the video, and you could practice labeling and making sure you know the different parts to kind of quiz yourself. So make sure you look at those two pieces also in this folder. The different circuits that are present in an X-ray machine, you have the low voltage circuit and the high voltage circuit. It'll make more sense after you've watched the video about the tube head, or I'm sorry, the X-ray tube. But the low voltage circuit is the part of the machine that operates the heating of the filament. So the low voltage current is what heats the filament. And even though this won't make sense now, go ahead and put in your notes that the low voltage circuit is controlled by MA, the milliamperage. We'll talk about that in just a second, but it's written lowercase m, capital A, and that goes with your lower voltage circuit to heat that filament. The high voltage circuit is what makes the cathode end negative and the anode end positive. And to do that, you need to kind of boost the electricity up a little bit, and that's why it's called your high voltage current, and that is controlled by your kVp setting. So it's a lowercase k, capital V, lowercase p. And again, at this second, those letters don't mean anything, but later in this lecture, we'll cover MA and kVp. And then also your timer has a separate electrical control. It is an electrical timer. They used to be manual timers, but as the film has gotten faster, and then we've converted even over to digital, which is even faster exposures, the timer has to be so specific and such small amounts of time or increments of time that they did have to go to an electrical or digital timer. Okay, the cathode end, and again, make sure you watch the video where I go through and explain the X-ray tube. But the cathode end of the machine, it is the negative electrode. The two electrodes that you have are the cathode and the anode. So the cathode is your negative electrode. Think about magnets, and when you played with magnets maybe when you were younger, the different poles of a magnet would be what we're talking about as electrodes. The cathode is where the cathode stream of those electrons begins. So it's called the cathode stream because the cathode is where that stream of electrons begins. Okay, the anode, which is the opposite end, the anode is the part that has the tungsten target, the radiator, and the copper stem. But that is your positive electrode. Okay, thermatic emission. In the video, I talk about how the filament is heated to incandescence. That just means that the filament is heated through that low voltage electric current until it glows red hot. That's what incandescent means. And your MA setting controls the thermatic emission. Thermatic emission just means the boiling off of those electrons. So when the electron cloud is formed, how many electrons that are present is your thermatic emission, and that's controlled by your MA. If you turn the MA up, you get more electrons, and if you turn it down, you get fewer electrons. Okay, the metal housing, that protects the actual tube itself from accidental damage. You're not hitting it on the wall when you put it away. You're not hitting it on the chair. It also grounds the high voltage components of the machine so that as you're adjusting it or setting things up, you don't get shocked. There's a lot of electricity running through these machines, so you want that to be protected to keep you safe. It also provides a surrounding for the tube to absorb the x-rays that are not part of the primary beam. If they happen to get out of the glass envelope, you want to make sure that they don't actually get outside the machine to reach either you or your patient. I've included a picture here. X-ray tubes used to be made very pretty. You've got some diagrams in your book that show you more what they look like now, but they're housed within this metal housing of the tube head, so you can't see them anymore. So what they look like isn't very important. But 100 years ago when they made these machines, they made them to be very pretty. They were hand-blown glass. They were different colors. This one's kind of a purple and gray. And the reason they made them so pretty is they were made by people who made art glass because they were visible. You didn't have a metal housing. You didn't have that extra layer of protection. And that's why so many people who worked with radiology in the early days later developed cancer or burns and things like that. So for safety measures, you have that metal housing. Okay, we're going to talk about the amperage. When we talk about amperage with the X-ray machines, we're talking about quantity or numbers, and in our particular case, it's the quantity of electrons that are present and that boil off of that filament. So the number of electrons that are present change how many X-rays you have. So if you're increasing the number of electrons available to travel in that cathode stream over to the anode, that changes how many electrons hit the target. In turn, that changes how many X-rays are made. So more electrons gives you more X-rays. Fewer electrons give you fewer X-rays. And that's controlled by the amperage of the machine. When I talked about the filament and the low voltage circuit, I said it doesn't take a lot of electricity to heat that filament. It's really all that it does. So in our case, we're not using an amp, we're using milliamps. So it's 1/1000th of an amp. And the traditional or standard operating range for dental X-ray machines is an MA of 7 to 15. So it will be referred to as 7 to 15 MA. Okay, voltage. Voltage is what's responsible for the quality of the X-rays that are produced. And I know that next two sentences look like mumbo jumbo, but the electrical pressure or potential difference between two electrical charges just means how negative is the negative and how positive is the positive. It's the difference between when you were a kid and you played with refrigerator magnets And we could, magnets, they were kind of fun to play with, but you could still touch them together. But then maybe, by the time you get to high school or middle school and you had science class and they had stronger magnets, and so the negative and the positive were very different. You could, put them together and they would pull together really fast. But if you put a negative side to a negative side, the poles of that magnet wouldn't let you push them together because they were stronger. That deals with the voltage. So in our case, how negative is the cathode and how positive is the anode? That's what's determined by our voltage. And when it says determines the force that attracts the electrons to the anode, remember, negative electrons are going to be pushed away by the negative cathode at the same time they're being pulled by the positive anode. So how strong is that force that pushes and pulls those electrons across? That's determined by your voltage. And in our machines, we actually have to use that higher voltage circuit. And so we're going to increase our voltage. I've gotten ahead. We're going to increase our voltage to kilovoltage, which is the kVp abbreviation, stands for kilovolt peak. And a kilovolt is 1,000 volts. So instead of saying 75,000 volts, you would say 75 kVp. And the operating range of most dental x-ray machines is 50 to 100,000 volts. So the easier way to say that is 50 to 100 kVp. Okay, back to the previous slide. When you increase the voltage, or the kilovoltage in our case, that's going to make the electrons travel faster, so they're going to hit harder. When you turn the kVp up, you get stronger x-rays, and when you turn it down, you get weaker x-rays. And so that's how voltage affects your x-ray strength, or the quality. The last thing on this recording is going to be the deadman switch, which sounds kind of ominous, but the deadman switch prevents overexposure to your patient, because when you press the button, the machine is going to go through a cycle. You'll press the button, the low voltage circuit will heat the filament. Once that happens, the machine will kick in the high voltage circuit to make that negative cathode and positive anode kick in, and for the preset amount of time, it will create x-rays. Once that preset amount of time has ended, the machine powers back down. Whether you let the button go or not, it's not going to create any more x-rays. You have to release the button on the switch and then press it again to create more x-rays. They call it the deadman switch because if you press the button and killed over dead, you wouldn't kill the patient too, because you're not going to keep making x-rays. It only makes x-rays for that predetermined set amount of time that you put in the timer. Once that time's lapsed, it won't make x-rays again until you release, let it reset, and then press the button again. So this is going to be the end of part 1. We'll also have a part 2 to this lecture.